Hello, guys. So today we're hosting the demo of Pruvendo team for the Oracle's contest in the DeFi governance. So guys are going to present the solution from the submission to the contest and explain us and give us more details about it. So please, Sergey, Vadim, so the floor is yours. If you need to share something, the sharing is open.
Okay, so hi everybody. My name is Sergey, and today we're going to show you our solution regarding not Oracle contest. So the main idea is to provide some kind of stable token, and all the rates are based on the external Oracle. Currently, we take all the data, all the rays from cx.io, one of the most reliable and important exchanges for today. And talking about technical details and DEM myself, Vadim, please go ahead.
Hello everyone. As Sergey said, the main goal of this software, this project, is to provide ton USD quotations stream from outside of the blockchain, from off-chain to the blockchain, and our software, our solution have three different parts, just following contest proposal. It's a really straightforward architecture. Three parts. One part is off-chain not validator. Off-chain not validator is a script which gets exchanges, gets quotations from some exchange. In the case, it's cx.io, but it can be easily changed to any other else. And it's this off-chain software sends it to some proxy contract called not validator contract. Every not validator, every guy who wants to send its version of quotations should deploy such contract. This contract used for as a proxy for paying not electors methods costs. And for some caching. It's the second part of system. And the third part is not elector contract. It's one contract for the whole system, which makes decision, calcs final quotations, makes not blocks, not our stream of our sequence of quotations, final quotation, final results. We call the sequence of not blocks. As normal blocks in blockchain. That's really straightforward architecture. And now I can show a little how it works. Can I?
Yes, you can.
Share screen. Yeah. Okay. Now in current submission, we have like two ways to run our software. To bash scripts, which runs our validation system with Tonos SE, local software edition, startup edition, local edition. But it can be easily changed to real blockchain mainnet or devnet. And two scripts. Simple run.sh is just a demo script which launches one Python script for all, which receives which listens events from not validator and not elector, which runs only one not elector and only one not validator, and just shows how it works, how it acts. The script is really simple. We make config for the whole system. The main reason why we generate config with script just because we have to set current time there. We deploy fake depool. We deploy not elector, we deploy not validator, and we run validation. Okay, let's see how it works. Wait a few seconds. And this JSON lines is events emitted by not validator and not elector. Here we elected one not validator. Here election is over, and now sometimes validator asks an elector asks validator to reveal encrypted quotation. Here, validator emits event reveal please for some quotations hash. Off-chain part finds salt and real quotation value, sends it to not validator contract, to proxy contract. Not validator contract checks its hash and provides it to not elector. And here we have one USD cost calculated event, and here we see sequence of such pairs. And in config we have 40 seconds duration for our validation, and after 40 seconds it's become unavailable. So here you see it. Only one validator, only one elector. And here we use just real quotation from real exchange. And we have a second variant how to launch it. It's run se test.sh. This script do kind of the same, but here we have more than one not validator. We run a little bit different script, which does not listens for electors events, because in previous version we listened electors event only for debug output. And in this case, we don't use real exchange. We have fake quotations from some JSON file, which generates with a simple Python script. And after the work of this script, we get some result.json. This file contains a sequence of events emitted by not elector. So here we see quotations calculated by it. This is values we got with Sergey just 10 minutes ago in 14 seconds validation. Here you can see the gap between cost and time. Here we use time from the beginning of validation just as cost for a simpler comparison. And I can I can launch it. And here we have to wait about 1 minute, 40 seconds for validation and a few seconds for deployment, config stuff, and so on. When we are waiting for this, you can ask any questions if you have now.
Can you show anything working on the real network?
Yes, thank you. Just guys, please raise your hands. Yeah. So Boris, please. What was your question? Can you say it louder?
Yeah. Can you show anything working on the network, test network? Because like systems showcased on local node usually are not working on blockchain.
Now I tested it with DevNet, but now I really have no credentials for Ruby's multisig. If you have the one, we can retune it.
Yeah, sure.
It works on DevNet also, but with bigger latency.
For testing purposes, I really recommend Fludilka testnet. It's really stable. It doesn't get wiped every now and then. So yeah, and
what do you recommend?
FLD.
Network, yeah.
Castler, GQL.castler.net. So Fludilka, that's a test blockchain supported by community.
Okay.
It's really nice, stable, and yeah, it works.
So Vadim, maybe it's a good idea to just set up this config for this FLD in a network, then capture some video and send it to the team after the meeting.
Yeah, and also please provide some guidance for jurors to repeat this themselves if they want to deploy.
Our submission already contains such guides, I guess.
Okay, very good. Thank you, Boris.
It's really simple. You just install necessary Python libraries and tune config, generate config, network durations, credentials, and it goes on.
Okay. What is one USD cost that you use there? So what does it stand for?
It's how much nanotons one USD costs.
How much nanoton? So it provides the cost of ton crystal, actually.
Yeah.
Does it support different currencies? And if yes, so how is it configured?
Now not, but it can be extremely easily changed. That wasn't our goal, I guess. But really, it's one line in the script.
Can you show how, if possible now?
Yeah, okay. Just async post request to CEX.
And do you have some kind of DAO or consensus mechanism to add supported streams, or is it configured by each validator separately?
Can you repeat? I didn't get the question.
I mean, that's right now. So this configuration runs in just with a hard-coded pair that is extracted from a specific endpoint or specific exchange. But if this system goes to production, so it means that at least there should be the possibility to add additional endpoints and other currencies for other contracts to use the quotations. So do you plan to add some distributed governance mechanism for taking such decision on adding such pairs, or how do you plan to operate this?
So,
Okay.
Vadim, go ahead.
Okay. I guess the source of quotation is not validators' responsibility. So everyone can make this decision by itself, by himself. And yeah, we can provide different functions for the set of exchanges, but really everyone have to make this decision by himself.
Yeah, but in this case, how do you prove that the data that is provided by a specific node validator is correct one? So do you have some kind of consensus between validators?
Our consensus algorithm is in the node elector. We sort quotations just like it's described in contest proposal. We sort quotations. Our result is medium quotation, and we recognize lowest and highest 25% as pre-malicious ones, and we calculate some special ranking for all node validators. And if the rank keeps higher than some value for a given number of non-blocks, this node validator becomes slashed.
So you have slashing mechanism. That was my second question.
Of course.
And how does it work, the slashing mechanism? And what is
the slashing? Okay, every node validator contract, it's not only proxy, but it should have the pool stake. Should keep the pool stake on it, and at the end of the pool's round, this the pool stake returns to its previous owner. But when node elector call slash method in not validator slash method, the value of whom we return the stake changes to node elector or something like that from previous one. Now we just put it in the trash, but it can be it has to be tuned after in the following stages of node system. Now we just have no agent who has to receive such stakes.
But that means that any node validator can slash any other node validator. Or
no. Only node elector can slash node validators.
Okay, and how does node elector understands that this node validator is performing in a malicious way?
Node elector thinks that node validator is malicious. In case, then node validator sends a quotation in highest 25% or lowest 25%, no, like too often. In the contest description, we have strict formulas, and our solution follows it strictly.
Okay, very good. Next question is about the economy, and so The first question will be how one becomes a node elector. So should he use some nodes tokens?
Not elector is should be a system contract. It's only one for each
sorry, not validator.
Not validator.
Validator. I mean, yeah.
In current architecture, every stakeholder, not only real validators, but every folk that has its own stake can transfer stake to not validator contract and take part in not validator selection.
Mm-hmm. But the stake is accepted in Ton crystals or in some other tokens?
In Ton crystals, yeah. Like all other, like all the depool stakes.
So typically you use the same depool contract as
absolutely
the one
as it is
validation. Mm-hmm. Okay. So what do you? What is the economics of this system? So how do not validators receive the reward and from where?
Well, now it's not okay. How they receive their prizes? It's not part of this project. Every successful participants of a not block calculation should receive some prize, and we collect this information, collect the list of successful participants, but it has to be sent to some not banking system which does not exist in terms of current implementation stage.
Yeah, it's clear it doesn't exist now, but maybe you already have some thoughts on how to implement this and how we can specify this in the contest terms for the next stage.
Okay.
What's the vision?
As I understand, it's no, like I said before, prizes for successful blocks participants. Maybe only one controversial moment is when they has to receive this reward instantly, or maybe we have to deploy some specific contract which will collect its rewards and unlock after end of validation period if not validator did not become malicious. Malicious.
Okay, so after some locked period. Okay, in this case, if any consumer of this data would like to use these data streams that are provided by not validators, so where they should get it? So from which contract?
Now, okay. The goal of the system is to provide sequence of not blocks which contains quotations. Which stream now it works as a sequence of events. Not elector emits events, and you can just subscribe to it and but in real node system, when we will implement the following stages, it has to be sent to some not banking, and I guess this not banking will be able to will have to have mechanism to publish how to publish these quotations.
Okay, and in this case, so how many different data sources does the system support? If we speak, for example, about the quotation of currencies, yes, for example, ton, crystals, or maybe BTC or Ether, whatever. So how many consequent pairs does the system support? So is it possible for not validators to submit blocks with data about, I don't know, hundreds of different currency pairs?
Now we support only ton USD pair because of NOT's goal. We have to make stable coin. NOT is stable coin. We sell NOTs for tons and ton coins for NOT coins. And it's only one pair in this case, in this system, and we have to know tons cost to know price, how to price, how to know how to sell nodes.
Okay, thank you. How many validators are the absolute minimum for the system to be reliable? How many? I will rephrase. How many not validators are needed to reach consensus?
We have no strict limitation now. For example, when I launched simple run script, we used one node validator, and it kind of works. But I guess the main problem is not how many node validators we have, but can we believe that half of node validators are not malicious? If we have enough big number of node validators for satisfying this requirement, it seems good.
But you estimate, so how many is absolute minimum?
I guess about maybe 10 or 20, but if we have a small number of node validators, they have to make really big stakes.
What is that was actually the next question. What will be the minimum stake for such a node validator?
This question is more about economics, but not software development.
No, just the grade. So is it tens of thousands of tons? Is it hundreds of thousands of tons? So what is your expectation?
My expectation is that depends on it depends on how many participants will take part, and how easy it will be to deploy, tune, and use this software. If we have, if it's all of this really simple, we have plenty of node validators. Minimal stake can be about, I don't know, thousands of tons. And if it's difficult, or for example, if it's allowed only for not for only stakeholders, but for real real validators, stakes should become bigger, I guess.
Okay.
Actually, I think that anyway, the deposit should be big enough to make any attempt to hack the system very expensive. So we need to talk about, say, a few millions at least as a total deposit for all the node validators.
Okay, Thank you. The next question is for how long the validation period lasts and the election period. So how they are linked together. So when the election starts, when the validation starts, how long does it last?
It has to be connected with real validation period, because we use real depool stakes, and we destroy our node validators at the end of depool round. So it has to be connected with real depool timings. So, for example, one depool round is validation period, and one depool round before, or something like that, is election period.
Okay, so it works pretty much as a regular validation.
Yeah.
All right. Actually, I don't have any more questions. Guys, do you have anything else to ask? Three, two, one. No. Okay. I hope that my questions will help jurors Alex, I see.
So, and to try to run this on the local computer, what is needed?
As startup edition, blockchain startup edition, and install required Python script, Python libraries, like it's mentioned in requirements 16.
Okay,
That's
clear.
all.
And then you have to run tests, run test node elector, run test node validator.
No, we have bash scripts, run SE tests and simple run SH.
So, and if you don't, you have to run them in parallel, or
one or another. It's two variants. Simple run runs only one elector and one validator in the same script. Run SE tests uses fake data and run a few validators in parallel.
Okay, and simple run is on chain or off chain also.
Both variants is on chain. Both variant can be deployed on any network you want. It can be tuned in config.
Okay.
Config.py. Here we have network.
Okay. Clear. Thank you.
One more question about the node elector. So typically, do you plan that it will be a single contract deployed once and then operated by a set of node validators, or it will be, I don't know, periodically redeployed? So how does it work?
In current architecture, it should be deployed for once for each validation period.
So in each validation period, there will be another elector address.
Yeah.
Okay.
But it's I hope that such questions will be answered on the following stages when we will write parts which connects different nodes, which will connect different node models with each other. So we have to have some banking system which keeps set of tons to give it to auctions. We need auction system, auction service. We need we need currency as it is. We need different parts, and it has to be connected in some way. And I hope it will be one of next contests, how to connect it between each other.
Okay.
I don't know how it will be, but I hope we'll have.
Yeah, I think that maybe it's worth also to visualize how the systems will be interconnected and how the one system depend on another, because there is a lot of text definitely in the initial essay by Mitya. So, and maybe not everything is crystal clear for everyone. So, yeah, if you can take it on yourself and visualize, so it will be really big help for jurors.
I guess I understand. I understand how it should work.
Okay.
The only one unclear point is how not coin should work. Should it be like tip-free or native coin or something like that?
Mm-hmm.
I don't know.
Okay.
But the rest parts are not absolutely clear, but understandable.
Mm-hmm. Yeah, I'm asking about this because in terms of economics, all the transactions that not validators do, so they burn some gas for doing this, and collector burns some gas, and all of this should be funded from some source, typically from the consumer of this data, and that's why I'm asking, so how do you see the economic part here, and who will pay for all this gas?
Okay, I see. In current version, all gas paid by not validators. This one of goals why we have proxy contracts, not validator contracts, is to pay not electors calls, and we have a simple mechanism in not elector which helps us not to. We have some threshold, some minimal balance in not elector. After reaching this threshold, not elector starts to take extra commission from not validators. Well, economics is like I am not validator. I wanna get my not reward, and to take part in this process, I have to pay for my gas, for my not validator proxy, and also for my not elector.
Okay, thank you. Alex, do you have some other question?
No, thank you. Okay.
Yeah, I do this. Yeah, I looked at paragraph describing running on chain, and yeah, it requires additional comments. It's definitely not obvious, and I can help with providing test tokens and configuration for test networks. But yeah, at this moment, running it on chain, it's very unobvious.
Mm-hmm.
And that's what jurors should know.
Yeah, if you can improve this, guys, please. So it will really help. Okay, so any other questions, please? Okay, so 3, 2, 1. No questions. Okay, guys. So thank you everyone for your demo. So now it's I hope it becomes more clear for jurors on how to assess your work and what it includes, what it can and what it cannot. So I will share this recording with the jurors in both groups. So yeah, if you are a juror and you are listening to this, so and you have any questions until the very last moment, please do not hesitate to contact Sergey or Vadim directly and ask your question. So thank you guys and have a nice evening.
Bye
Thank
bye.
you very much.
Bye.
Bye.
Bye bye.